Hello everyone and welcome back. We've got another screencast today and we're doing number again. We've got product of its prime factors and I really enjoy this. It's really quite creative. So as long as you know your prime numbers, then you're going to be absolutely fine. It might seem complicated, but it's actually quite enjoyable as we go through. So once you've learned it, you'll enjoy doing it and creating these prime factor trees and whatnot. So what is a prime number? We've done this before. A prime number is a number with only two factors, 1 and itself. Remember, factors are numbers that multiply together to give us another number. So we could say, okay, 12. Factors of 12 is 1 and 12. It's 2 and 6 because 2 times 6 gives us 12. And it's also 3 and 4. 3 times 4 gives us 12. So 12 is not a prime number because it's got lots of factors. We're looking for numbers that don't have a lot of factors. In fact, they've only got 2 and they would be 1 in itself. So let's look at a cast iron example of a prime number. We've got 5 because 1 times 5 is 5, but nothing else. It makes it prime. People think that 9 is a prime number, but actually it's not. 1 times 9 is 9, 3 times 3 is 9, so it can't be prime. So 5 is prime, 9 is not. So when we're doing our prime numbers, normally we need to know a whole list of prime numbers, but really for our factor trees, we're going to need to know the first 4 really, really well. We're going to use these numbers repetitively to give us our answer. And I'll go through a number of examples for you step by step to help you along that way. Just remember that 1 is not prime because it doesn't satisfy the rule. Remember, you have to have 2 different factors. It needs to be 1 and itself, not 1 and 1, because that's the same positive integer. 2 different integers for that to work. Hopefully that makes sense. What is a factor tree? So do not worry about this. I'm going to give you some examples. They're just a way for us to find the product of primes, which we're going to go over, okay? Here goes examples of some factor trees. Ours are going to look a little bit different, but that's what they look like. And we're going to crack on with an example. So how do we work out a number as a product of its prime factors? Well, it's very, very, very simple once we get going. They look like trees, kind of. They've got branches, basically, is what we're trying to say. We're going to find out 24 as a product of its prime factors. So the key thing here is we're going to use prime numbers to do this. So always, when we're looking at factors of a number, we're always going to have one of those numbers being prime. And I always have it on the left here. So what's a number that's prime that will go into 24? I'm going to use 2. 2 times 12 will get me 24. So I'm going to write that down now. 2 times 12 gives me 24. Now 2 is prime. Remember, one of these numbers always needs to be prime. And you will always have the ability to have a prime number there as well. Just remember that. And as I said before, the numbers we're looking for are 2, 3, 5, and 7. They will generally be the numbers that we're going to work with all of the time. So now 2 is prime, but 12 is not. So let's think of another 2 numbers that multiplied together to give us 12. One of them needs to be prime. I'm going to use 2. So it's going to be 2 times 6 gives me 12. Now 2 is prime. Is 6 prime? And the answer is no, it's not, because we've got 1 times 6 and 2 times 3. So that's what I'm going to do at the end. I'm going to go again and say, okay, I got 6. I need 2 times 3. And both of these numbers are prime, so we know that we've finished this prime factor tree. So how we write our answer is very simple. We say 24 equals 2 times 2 times 2 times 3. Can we see that? And sometimes you'll be asked, and this might not make a lot of sense to you at the moment, but I'm going to write them all day today anyway, which is if you're asked to write it in index form, it looks like this. 24 equals 2 to the power of 3, because there's 3 2's, timesing by 3. Do we see that? We've got 2 times 2 times 2. That's 2 to the power of 3 times 3. And that is it. That's how we do them. So I'm going to do one more with you before I let you loose on the next slide. 36. Maybe you could try and do this along with me. One thing I would say is, you may look and go, okay, well, what about 12? I could have done 3 times 4. It doesn't matter. You can still do that. You can still do that. You will amazingly get the same answer as I have. You just get it in a slightly different way. So let's just go on 36. You think of a prime number timesing by another number that gives us 36. I'm going to use 3. So here we go. 3 times 12 gives me 36. Now 3 is prime, happy days. 12 is not. So what two numbers will multiply together to give us 12? One of them needs to be prime. It would be 2 times 6. And you can see here a little pattern emerging that we're now very similar to over here, aren't we? What two numbers multiplied together will give us 6. One of them needs to be prime. In fact, both of them are going to be prime because it's going to be 2 times 3. And they're both prime, and we know that we can't do any more, and they are finished. So my answer is 36 as a product of its primes would be 2 times 2 times 3 times 3. So I've got 2 times 2 times 3 times 3. Now, in theory, you could write those in any order, but it's really good practice to write them from smallest number to largest number. And then in index form, it would be 36 equals 2 squared times 3 squared. All right, everyone, it's time now for you to give this one a go. This one might seem very, very difficult, but trust me, it won't be. You'll absolutely sail through. Remember, what numbers will go into 150 that are prime? I'm going to give you a little helping hand. We could have 3 or 5, so you could use either of those to start us off. Pause the video, give it a go, come back and see if you've got it right. So let's give it a go now. What would I start with? The two numbers that I worked with were 5 and 30. Now remember, you could have picked something else, but that's what I used. Okay, you will eventually get the same answer as me. So you may have gone and said 3 50s. Yeah? 3 times 50 would give us 150. Doesn't matter. That's absolutely fine. You'll still get the same answer. But now let's go. What two numbers multiplied together, one needs to be prime, gives me 30? That would be 5 and 6. And then what two numbers multiplied together give us 6? We know this from all of them before, would be 2 times 3. And you probably see that your numbers are all the same. Even if you use them differently, you'll still get the same answer, which is 150 as a product of its prime numbers is going to be 2 times 3 times 5 times 5. And that can be written in index form as 2 times 3 times 5 squared. And it is time for the quiz. These aren't really difficult, but you know, as the numbers get bigger, we've got to really start to use our brain and common sense a little bit more. So I've given you some slightly bigger numbers to work with, but I know you can do it. You need to pause the video now, give this a go, come back and see if you've got them correct. All right, everyone, here we go. Here is our answer. This is how I did it. Hopefully you've got exactly the same answers. That 96 was quite a long one, wasn't it? But we eventually got there, and if you can get that one, you can get anything. The 84 was surprisingly short, and sometimes you can get them and they're ridiculously short. That's what can happen. So certain numbers, like we've got, well, I mean, if I just take a basic one like 8, you'd have 2 and 4, and then 2 times 2, happy days, you're done. But these ones are a little bit longer. Hopefully you've done them really, really well and you've got them correct. Remember, if you'd like a copy of these electronically, please get in contact with me via the comments section below and I can send you an electronic copy of all these. But, you know, make sure that you write them out. Revision cards are so important. They keep everything fresh. It's called interleavering in our mathematics teaching world. As always, I've absolutely loved teaching you and helping you with maths today. Hopefully you feel even better than you did before you started, and I haven't thrown you with any of those questions. Until next time, goodbye.